Hello everyone, welcome to our project Signal-Based Object Detection and Alert System using ESP32 ultrasonic sensor for real-time object detection and a relay alert system. This is done by Vikas, Pinout and Harshvardhan under the guidance of Professor Narendra Bhagat, Professor Reena and Professor Najib Gatte. This is a simple real-time system I have built to detect object nearby and give instant alerts. Today I will walk you through how it works, show my hardware and explain the code setup and step by step. So first we will walk through the introduction part, introduction to signals and system. Modern embedded systems use sensors to catch signals from our environment and convert them into data and respond automatically. Here, an ultrasonic sensor helps the ESP32 detect distance, processes the data and triggers output like LEDs and display. First, the input comes and then it processed through the microcontroller and then output visual on the OLED. So next, it's project objective. There are three main goals. First, to detect objects in real time and measure their distance. Second, to display those measurements clearly. Third, to warn us with LED if something comes closer than 20 centimeters. Next, we will go to the system architecture. At the heart, we have a SP32 microcontroller. The ultrasonic sensor measures the distance to any object in front of it. The OLED screen shows the distance, and LED gives a visual warning if something is too close. All these parts work together according to the circuit diagram, which you will see in these slides. So next we will discuss the hardware components. So we use ESP32 microcontroller, HSR04 sensor, OLED display and LED. So what is ESP32 microcontroller? First of all, we will see that it is a microcontroller which is a dual core 32-bit processor at 240 megahertz and it has a built-in Wi-Fi and Bluetooth connectivity. The ultrasonic sensor has range from 2 centimeter to 400 centimeter. We can set any range. For this hardware example, I set 20 centimeter. Accuracy is plus or minus 3 mm with the 15-degree beam angle. The OLED is 128 by 64 pixel, which read LED for alert indication. So we will go through the working principle. First, the ESP32 sends a pulse to the sensor. Then the sensor listens for its echo. Then ESP32 calculates distance based on how long the echo takes to return. If something is within the 20 centimeter, the code turns on the LED. The LED display updates the measured distance instantly. Then the hardware demonstration. The signal processing flow. How the signal process flow from input, then processing, then output. The sensor captures the pulse from the input and processing the ESP32 calculates the distance and check if it's within our threshold. An output LED lights up if the distance is short and numbers update on the display. So next the signals and simulations as we discussed the echo pulse duration, the processing, the distance calculation, then output the LED states change. Let's begin with the code. First the are the header files. These three are the header files. That is hash include wire, hash include output, the hash include ADA fruit. First is add the support for I2C communication used for OLED display. And second is include graphics function for the OLED. Then third include function for controlling the OLED display. Next the defining screen width of OLED that is 128 pixels. Then second is to height of the OLED screen to 64 pixels. Then next is to create the display object to talk to the screen. The next is to define the pins, the sets GPIO 5 as the ultrasonic sensor, that is to trigger pin, and the echo pin is 280, the LED pin is connected to 2. The long duration stores measured echo time in microseconds. The float distance will be used to store distance in centimeters. Then this is the board setup. Begins with 11200 the baud rate. The pin mode is track pin output. Set the trigger pin as an output. Then echo pin as an input, and LED pin as the output. The next we initialize the OLED. It's safe by using if condition. Starts the OLED display at address 0 into 3C, gives error if not found, and displays the clear anything previously shown on the OLED. Then display set text size, makes the text small. Displays set text color, which makes in white. Then display cursor that x equals to 10, y equals to 25 size. Then the display the distance alert. Then this is the delay that is 2 seconds before the beginning of the loop. And this is the main loop, starting of the main loop. Void loop, the repeats forever once setup is done. The first is the digital write track field loop. It turns trigger off to start pulse, then delay of 2 microseconds. The digital write track pin high that sends trigger pulse on pin number 5. The delay of microsecond that is 10 microseconds. And digital write track pin low returns of the trigger pin again. The duration is duration into 0.34, that is sort of the sound divide through to convert this into centimeters. We can get the readings in centimeters. And the next are serial print distance. That this print distance is also print distance in serial print in centimeters. That's to this print distance to the serial monitor for debugging. And display clear display makes already for new value. Then this makes the bigger text. Then sets position. Then shows value and centimeter on OLED. This displays update the OLED to the new data. Then the if condition. So if distance is less than 20 centimeter, turns LED on. Otherwise, LED is off. That is low. The high is for the on condition and low is for the off condition. Then there is a delay of 0.5 seconds before the next measurement. So this code repeatedly measure distance, updates the OLED display, and lights the LED when something gets close.
So this is the hardware setup in which we use ESP32, ultrasonic sensor, OLED, resistor, breadboard jumper wires, and LED. So when we power up the breadboard setup, the ESP32 starts running the code. The ultrasonic sensor keeps checking if there is anything in front of it. The OLED display shows measured distance every half cycle. So if you move your hand or any object close to the sensor within about 20 centimeter, the ESP32 instantly detects this and turns on the LED as warned. So let's see. I'm using my hand. So it is about 20 centimeters, so it's not glowing. When I move my hand near the hardware setup, it glows. See. So it is now 18 centimeter, 16, 12. It's varying as I move my hand or object. When you move hand away, the measured distance increases and the LED turns off. So this system provides fast visible feedback that everything is working and demonstrates real-time distance sensing with both digital OLED and visual LED indicators.
Results and observation. The distance for you can see that for the 5 centimeter it's glow as we have said to 20 centimeter. The in which below 20 it glows and above it turns off. So the OLED displays shows some variation in the centimeter because it has some less accuracy as shown in below. Average accuracy 98.2% and its response time is 100 milli per second. So next, the applications and future enhancement. The project can use wherever distance sensing and instant alerting are needed, like parking assistant to warn drivers when they are too close to obstacles. The obstacle avoidance in robotics helping robots navigate safely. The industrial automation, where machines need to detect nearby objects for safety, car door automation, security system, etc., etc. The future enhancement, the future enhancements send distance alerts to mobile phone or display them on web page using Wi-Fi or Bluetooth. Add data logging, use multiple ultrasonic sensor to cover a wider area to achieve 360-degree sensing. Enable object classification using more advanced sensors or machine learning for smarter reaction. In short, the project is for parking sensor, robotics, security system, and where you detect object and get instant alerts. In the future, it can be upgraded with wireless alerts, cloud data logging, or multiple sensors for better coverage. Conclusion project is successfully demonstrate signal processing and concept the practical is with implementation. Thank you for your attention.